Good day, everybody. This is our first topic for this tutorial. I will be imparting to you first on the subject about plumbing. The mechanical, electrical, plumbing, fire protection. So we touch first on plumbing because this is the most controversial profession. The profession may be interacted by many professionals, mechanical, chemical, civil engineers, or engineering. So, our profession, plumbing engineering, will concentrate on how plumbing engineers delivers their design scientifically. What is plumbing engineering? Plumbing engineering is a professional discipline that applies scientific principles and techniques for the design, installation, and operation of plumbing system involving storm and sanitary drainage piping systems, drain waste and vent system, plumbing facilities of buildings, healthy ventings of fixtures, hot and cold water supply piping system, gas piping, swimming pools, water feature, fire protection system, irrigation system, private water system, sewerage disposal system within or adjacent to any building and other structures, operation and maintenance of plumbing equipment and appliances, and some more. You know, when I say a professional discipline that apply scientific principles, nothing more or less the same as the other discipline like mechanical engineers, because we apply also physics, mechanics in the plumbing engineering. We apply mathematics in plumbing engineering. We cannot solve problems regarding heat transfer when we do not know how to design for the hot and cold system. That's why plumbing engineering is a discipline that applies scientific principles and techniques. It applies physics and mathematics, the same as other disciplines. In this topic of plumbing engineering, we will apply the basic principles of hydraulics. You know, hydraulics is the main course of civil engineering, mechanical engineering, chemical engineering, and other professions. That's why they said, your profession, plumbing engineers, are conflict with our profession. That's why in some other countries, a plumbing engineers is managed by the mechanical engineers. So, if the plumbing engineering is the same discipline applying scientific principles and mathematics of other disciplines like mechanical and electrical, chemical and civil engineering, this plumbing engineering should know more about hydraulics, because the distribution of water system within the building, either it is a high-rise building, the plumbing engineer knows about it. That is his specialties. Okay, basic of hydraulics. Say for example, statics, the liquid at rest. In the body of water, static or water at rest, when you submerge an object at the bottom or at any point within the body of water, the depth of that object represent a certain pressure, a pressure of WH or omega H times specific gravity. Like for this one, this is the triangular hydraulic presentation of pressures in the body of water. The pressure at the bottom, as we plumbing engineers envision on how the pipe is being submerged with water within a building, is a triangular pressure like that body of water. It is static. But when we have a pipe that is either it is submerged, but there is a force through a pump, it develops a head. So for example, when we transfer water from one point to the other point, to the higher elevation, it develops a pressure higher than what the static pressure is. Because if we consider this thing, this one here, this whole thing here, we consider this as a water tank or the storage tank, and we put a submersible pump within the tank, the pressure developed and the head developed is the head that is developed by the pump itself. The head is equals to VO squared over 2G from physics, which equals to velocity initial minus velocity final, which is equal to 0, is equals to 2gh. That is from physics. So the principle is what the basic principles when we apply here in our hydraulics inside the building. When we distribute water, when we distribute the wastewater, when we distribute the hot water system, it is the same principles as what we can envision on a basic of hydraulics. Let us consider the hydraulics of a building through this anatomy of plumbing in a building. How the hydraulics work? Okay, the conveyance of water inside the system of plumbing within a building is being worked by hydraulics. That's why ang unang salvo natin, ini-explain kong basic ng hydraulics muna para malaman natin na plumbing really a hydraulics. It is really a hydraulics, nothing. But when you apply hydraulics, there is physics, there is mathematics, there are formulas, lot of formulas. We can apply the RC Wisbach equation. We can apply Hessian-Williams equation. We can apply Manning's equation, the Thomas-Bach's equation, the Moody's equation. So we can apply it all to a hydraulics. That's why a building will not work without hydraulics, because the conveyance of water through pipe is hydraulics. Okay. That's why plumbing engineering is really a must. A plumbing engineers is really a must, because they are the one that understand the operation of plumbing in the system of a building. Okay, let us consider what I have explained, the basic principles. The basic principles that we will have, like I explained to you, transfer of water from a cistern to the overhead tank is really hydraulics, truly hydraulics. But because hydraulics here in our course in mechanical engineering is also a major subject, plumbing engineers talking about more mechanical engineering because that is also hydraulics. Okay. All things here, a conveyance of water from storage of water below to the storage of water at the highest point of the building. So we will consider in solving the riser pipe. Ang riser pipe is to size the riser pipe, kailangan mo ng mga hydraulic principles. There are losses. May mga losses yan sa pipe. So, ang mga losses ng pipe natin, they may be a friction loss that is applied through the formulas of the RC Wisbach formulas or equation. There are friction losses due to friction of the pipe as we apply Hessian and Williams equation, or a Thomas-Bach equation. There are losses because when you speak of water inside the pipe is being pressurized, and the pressure that will create a velocity, that is they call it velocity pressure, will create a heat like a stone that you throw from the bottom to the top until the stone will stop on its velocity and fall it down. That is the same principles in physics. Okay. But here, when we throw the water through the storage at the top of the building, it stays there and being collected by that storage. And that storage that collects water will also distribute water down feeding to its floor where the tenants are living. Okay. We will talk about hydro-pneumatic system also. We will design hydro-pneumatic system. We will specify pump that is being designed through hydraulics. We will specify loading, the same as what structural engineers do. They have the wind load, they have the dead load, they have the live load. The same also, we have also loading in the plumbing system. And our loading is expressed in a fixtures unit. That is what we are indebted to Dr. Roy Hunters. Utang natin yan sa kay Dr. Roy Hunters. As we go along, yung mga fixtures unit natin na yan, malalaman natin saan ba galing yan, fixtures unit na yan? Dapat ba natin malaman na tayong mga designer, yung load na yan natin makukuha na sinasabi ni Dr. Roy Hunters na kinukopya ng lahat na code halos sa buong mundo. Lalo na tayo dito sa Pilipinas, yung Revised National Plumbing Code na isa rin akong membro sa komite na gumawa niyan. Saan natin nakuha yan? Even the Uniform Plumbing Code, kinuha niya diyan sa kay Dr. Roy Hunters, na submit ni Dr. Roy Hunters sa Bureau of Standards ng United States. Yung International Plumbing Code, there are 32 states na siyang nag-adapt na yung mga states na yan, ginagawa nila ang bylaws nila, yung mga batas nila sa plumbing, International Plumbing Code. 32 states yan. Whereas the Uniform Plumbing Code, 12 lang, 12. Pero hiram yan kay Dr. Roy Hunters. Dito, may explain ko sa inyo as we go further. Kung magkano ba talaga, bakit meron tayong fixtures unit. Dapat alamin natin na tayo mga designer, kung tayo magdi-design o magsa-size ng mga pipe natin, either drain, waste, and vent na sinasabi natin, o yung distribution ng water system natin, the hot and cold, makukuha natin ang loading through Dr. Roy Hunter's fixtures unit loading. Okay. Itong hydropneumatic system natin, ay mabubuo ito kung alam natin kung magkanong loading, kasi ito ang sinusuplayan niya yung 3 floors, the upper 3 floors of the building. So, we will touch the hydropneumatic system as we go along. We will touch this distribution system of pipe from the storage down to every floor. We will touch about the bin stock. Bakit kailangan nating ventilasyon? Kasi kung walang ventilasyon, nababaho din tayo. Bumabaho. Dahil walang ventilasyon. Ha? Malalaman natin na kung walang ventilasyon, kung buo yung pipe natin, buo yung tubig sa pipe natin, yung pit trap natin, sinasipon lang. Ang labas na yon, kung walang drain, walang flushing, ang mangyayari doon, lalabas yung amoy papunta doon sa lahat na pit trap. Yung venting natin na nagsisil sa ventilation natin. Yung ano natin, yung horizontal vents natin, kailangan din natin malalaman ito. Yung horizontal drain, dito natin kinukuha ngayon yung mga fixtures loading natin. Ilang water closet, ilang lavatory, ilang shower, kung ano-ano pa na mga loading natin yan. Kung ano, depende yan sa gumagamit. So dito natin makukuha yung mga loading natin. It's like in the electrical code, may mga loading. Sa civil engineering code, may mga loading. Tayo din, sa plumbing engineering, may mga loading. You cannot design the system without the loading. So, horizontal drain, itong pinaka-importante sa lahat dahil dito kinuha ang loading, yung fixtures unit, na sinasabi ni Dr. Roy Hunters, na ang sabi niya, itong fixtures unit ng water closet, itong fixtures unit ng lavatory, o kung ano-ano pang mga plumbing appliance natin dyan, yung mga fixtures unit niyan, dinerive niya yan. How it was developed, I will discuss to you itong mangyayari. Dahil, ano bang loading kailangan natin? Bakit sinusunda na lang natin yung table na yan? Sapagkat ito ay nakasaad sa experiment na ginawa ni Dr. Roy Hunters. Sa dami ng mga loading, sa dami ng mga water closet, may mga probability. Kaya sabi natin, yung fixtures unit equivalent sa 7.5 gallons per minute or 1 cubic foot per minute. Hindi nangyari yan. Although yun ang dapat, pero hindi nangyari yan. So there was an adjustment made by Dr. Roy Hunters. Pero yung sa plumbing code natin, ganun pa rin. How many GPM o gallons in one fixtures unit? Ang sagot mo kaagad, 7.5 o 7.48 because 1 cubic foot is equal to 7.48 gallons. Pero hindi nangyari yan. Ang katotohanan, hindi. So, dito sa horizontal drain, itong the most controversial part of the anatomy of the building. The sewer stock. Dito din i-discharge yung horizontal drain natin sa sewer stock. Ang sabi pa nga, kung hindi ka inhinyero sa plumbing, you don't know how to design for plumbing. If you have a 100-story building, paano mo makukontrol kung i-flush, kung nagpa-flush yung ang mga water closets doon sa taas, na pinasok niya sa sewer stack mo into a 100-story building, anong nangyayari sa bottom of that building? Sa sabog. Kung hindi ka plumbing engineer, anong gagawin mo? Kagaya ng isang bato, 1,000 feet, 100-story building, ibagsak mo doon si taas, anong nangyayari doon? Ang impact doon, ang force of impact mo sa ilalim. It's like water happening. Paano mo ma-resolve yung problema na yan kung ikaw hindi plumbing engineer? We will go into that because that will be answered by the plumbing engineering or the plumbing engineers professionals. So, ini-introduce ko ngayon itong mga professionals na inaalam. So, hindi lang itong anatomy of the building na sa loob dyan, yung mga fire protection system. Pressurize yan. From the bottom up to the top. So, meron kang flow control of water. So, alamin natin sa buong plumbing topic natin. Di ba meron tayong fire protection sa buong plumbing topic natin? Meron tayong water distribution of the high-rise building. Meron tayong the hydraulics of the drain waste and bed of the high-rise building. So yun, ang kailangan natin alam. Hindi ito masusod na mga krokis-krokis lang ng mga draftsman. Masabi mo ba, ang kailangan mo, pagbagsak mo doon sa ilalim, hanggang ang ilalim, di 4 na lang ang tubo natin. Bakit hindi di 12? Bakit hindi di 14 na pipe? So, hindi pwede na sasabihin lang natin, pwede naman siguro yan. Kagaya na nangyari sa plumbing code natin. Kung ang plumbing code natin, nagsabi na, maski isang water closet, di 4 ang dapat na tubo sa horizontal drain natin. Pero, kung dito susundin sa kay Dr. Roy Hunters, maski di 2 pa pwede yan. Maski di 3 pwede yan. May 6 na water closet sa di 3, pero sa atin, siguro anong klaseng Pilipino tayo? Na hindi kung hindi tayo sumusunod, may sarili tayong version sa atin. Kaya ang iba sa atin, nag-scrutinize, na bakit hindi di 3? Bakit di 4? Ang laki naman yan. Ay sabi naman sa iba, economical reason. Kasi kung malaking tubo mo, malaking kita mo, malaking project na yan. Mahal ang di 4 kaysa di 3. Diba? Yun ang concept. Kung katotohanan yan, even YAP mo, even yung Uniform Plumbing Code, nare-revise na yun nila. Tingnan natin ang original dati, sa sunod natin mga topic. Matingnan natin ang original ng mga table na ginawa ni Dr. Roy Hunters, ni snapbit niya sa Bureau of Standard ng Amerika, na yung sinusundan ng buong United States at saka hiram ng ibang countries also na siya although some other countries describe their own water fixtures unit. Pero sa ngayon, dito muna tayo sa anatomy of the building, magkukonsentrate tayo dito kung paano natin ma-size itong sewer stack natin, ang horizontal drain natin, into how many intervals na kailangan ba natin mag-offset o whatever it is, velocity break o whatever it is. Yung rain stack natin na galing si taas, kailangan din natin na solve yan kasi kung malakas masyado yung hangin, I mean, yung ulan, umaapaw din ito. Pero dapat mayroong solusyon din ito. Kasi sabi nila, baha. Eh kung baha, ang dapat niyan, i-impound mo yung tubig. Hindi ilagay sa kanal. Ang kanal natin, nakadesinyo sa drainage na walang design. Kasi kung nakadesinyo yan sa rainfall talaga, hindi aapaw yun. Dapat hindi nag-aapaw yan dahil kalahati lang, kung sama na yung equation pa, kalahati lang dapat ang kailangan natin dyan. Ang tubig dapat sa isang pipe, kalahati lang. Hanggang dito na muna tayo. Itong plumbing in a building, alam ko maraming kulang ito. Kung itong building isang hotel, mayroong hot and cold system tayo dito. Kung itong isang building na nasa cold countries, ina-apply natin ito ng hydronics. Na kung tiglamig, malamig din ang sinusupply na tubig para sa comfort ng tao. Yun ang kailangan natin dito. Yung hydronics na yan ay isang malaking bagay na disenyo ng sistema sa isang cold countries. Yung fire protection system, hindi basta-basta with pipe system ka. Sa cold countries, napofrozen yan. Yung tubig na yan. Dapat walang tubig. Walang tubig. So paano naman kung walang tubig? Paano mag-action yan? So kailangan may disenyo yan. Kagaya ng pre-action type system. Alam nyo ba yung pre-action type system? So sa sunod, lahat na yan, malalaman natin. So para mayroon tayong makakwintas natin kung ano ba yung itong anatomy of the plumbing sa building. Ito na muna pinapakita ko sa inyo para at least malalaman nyo na talakayin natin ito. Lahat tayo ay sabay-sabay tayong matuto kung ano talaga ang plumbing engineering. Diniscuss ko sa inyo yung anatomy of the building. So i-class natin uli yung anatomy of the building. But we will discuss more further yung horizontal drain na kung saan si Dr. Roy Hunters na nagbigay sa atin ng lahat ng mga data na para sa design natin. Yung GPM required per fixtures unit, malalaman natin dahil ito ay pinablish niya sa Bureau of Commerce sa US, Bureau of Standards, under normal condition of flow. If the pipe were to flow full, pressure fluctuations will occur that could possibly destroy the seal of traps within the building. So yung made his conclusion or made about his formula through discharge or cubic feet per minute of cubic foot per second. But Manning was looking for the velocity, especially in the stream. The velocity of the stream. And he made a formulation that the velocity is equals to 1.486 over n times the hydraulic radius times raised to the power 2/3 times the slope or the square root of the slope. But in the simple way of hydraulics, Q equals to AV, area of the pipe times the velocity of the pipe. So when we substitute the velocity of Manning to the hydraulic capacity, which is Q equals to AV, the Manning formula will yield to Q is equals to 1.486 over N multiplied by the area of discharge, and The hydraulic radius raised to the power 2/3 and the slope, or the square root of the slope, where Q is in Q through a horizontal drain by using the RC equation at a fully filled pipe. Yun ang binabasihan ni Dr. Roy Hunter. He published it and it was accepted by the Bureau of